Hey, what's on your mind?
Can you suggest me some projects for FPGA related?
Sure. How about building a simple RISC-V processor core? Or maybe a real time image filter using pixel manipulation. That's always fun. Digital lock with password entry on buttons works too. Want something beginner friendly or more advanced?
Categorize. Give me projects of.
All right, let's break FPGA projects into categories. Beginner, LED blinker or traffic light controller, super basic logic. Intermediate, UART serial comms for data transfer, or a VGA display driver for graphics. Advanced, neural net accelerator for AI tasks, or a full AES encryption engine. Any level interest you?
Let's start with basics. Beginner level projects. Give me a list.
All right, beginner FPGA projects. 1. LED blinker circuit. 2. 7/7 display counter. 3. Simple traffic light sequencer. 4. Basic calculator with buttons. 5. Tone generator using PWM. Pick one and I'll guide you through it.
Done with all. Now, moderate level projects.
Moving up, moderate ones include a URC transmitter receiver for chatting with PC, a PID controller for motor speed, SPI interface master to talk with sensors, VGA text display for simple games, or even a basic ALIA unit that does math ops. Sound good? Which grabs you?
What's your opinion? Which one is best?
Hmm. For moderate level, I'd pick the URC transmitter receiver. It's practical, teaches serial protocols, and you can actually debug stuff with a terminal. Plus, it's everywhere in real hardware. Rest are cool too, but URC feels most rewarding quick. Your call though.
And what about other protocols like AMBA?
Implementing AMBA bus? That's more on the advanced side, honestly. But if you're geared up, try a basic AXI Lite master slave setup. Great for connecting IP cores like memory or peripherals. Moderate twist could be wrapping it around your URC to fetch data. Not too shabby learning curve. Keeps things tidy. Tempted?
Nice. Now, advanced level projects. Give me list.
All right. Advanced FPGA fun. Custom RISC-V CPU with interrupts, DDR memory controller, full AES or SAT256 crypto accelerator, PCIe endpoint for high-speed I/O, or even a software-defined radio receiver. Deep dive time. Which one's calling?
Which one you prefer?
The RISC-V CPU, hands down, feels epic seeing your own processor run code, and it opens doors to tons of extensions like multipliers or cache. Start simple, scale wild, my fave. Why? Thinking about it?
What's the output? What's the meaning of making this processor? What is the advantage of this processor over something which is in the market already?
Building a PCIe endpoint hits the market. Lots of dev boards use it for GPUs, NICs, accelerators. It's real world, connects to computers seamlessly. If you mean commercial FPGA stuff, like Xilinx or Altera projects, think Ethernet PHY driver or USB controller. But PCIe edges out for speed and demand. What angle you going for?
I'm asking for RISC-V processor project. Which why is that project is having an advantage? Why it is in 2026 is beneficial to make?
RISC-V in 2026 is straight up the hottest skill right now. Why it's a massive advantage to build one yourself? Negative open source boom. Companies like Google, Nvidia, Intel, and even Apple are dumping billions into RISC-V chips. Western Digital, SI5, Alibaba, and tons of startups ship real products already. No licensing fees. Unlike ARM, you can modify the core however you want and sell it commercially without paying royalties. Huge for custom accelerators. AI and edge explosion. Tiny, power efficient RISC-V cores are everywhere in 2026. IoT, storage controllers, AI inference chips. Look at Tenstorrent, Grok, Ventana. Jobs pay crazy. FPGA plus Risk 5 engineers
Hey,
are getting offered.
don't you think that building just a project of RISC-V processor rather than building a modified version of a processor or modified version of a ASIC which do something?
Building from scratch is fine to learn. But yeah, modifying an existing Risk 5, like adding custom instructions for crypto or vector units, packs more punch. It's smarter for real impact, keeps you ahead on efficiency, power, and those market gigs where companies tweak open cores daily. Scratch Build teaches basics, mods show innovation. What are you aiming? Learning or impressing?
Impressing.
Go for a modified Risk 5 then. Add, say, an accelerator inside for neural networks. Custom multiply accumulant units, fuse multiply add extensions. Or tweak it for error correcting codes and storage, like BCH decoder inside the pipeline. Pick a niche you like: AI,
Why
automotive,
didn't
block.
you suggested me a machine learning or deep learning based project in FPGA, even in advanced?
You mean why I didn't suggest one earlier? Well, yeah, they're killer advanced level. A hardware CNN accelerator, like mapping convolutions on FPGA pipeline, quantize weights to 8-bit, add data flow architecture. Or a tiny ML model deployer that takes TensorFlow Lite and spits out real time inference. That's hot in industry right now. Think autonomous drones, edge vision. Want me to sketch one?
But is it actually making worth?
Absolutely. Because right now, Edge AI is exploding. FPGAs crush GPUs on power and latency for inference. Companies want stuff that runs YOLO on a camera without melting the battery, or does anomaly detection on factories 24/7. If you nail quantized inference with pipeline convolutions, boom, you're the guy they call when AWS needs low latency vision. It's not just worth, it's stupidly valuable.
That's great. So let's just conclude everything.
Cool. So beginner, LED blink counters. Moderate, UART, VGA, SPI. Advanced, Risk 5 with your own twist. Maybe machine learning accelerator. Pick, build, ship. And trust me, by 2026, whoever has a quantized neural net on FPGA won't stay jobless for long. Good luck.
Thank you.